Hello viewers, I am Kausalya. Today we are going to solve a different type of problem, that is Bode plot is given and we are asked to find the transfer function. Okay, this is just an example. So you see, look at this Bode plot. So this is a typical magnitude plot, right? And this magnitude plot, when you look carefully, it has four parts, right? So this is our first part, and this is our second part, this is our third, and finally this is our fourth part, right? So from this given Bode plot, we are going to find the transfer function. So first, you see, this is our 0 dB line, and x-axis, as we all know, x-axis stands for the frequencies, right? So here I had mentioned 3 frequencies. Can you tell me why? Because whenever there is a change of slope, then there will be a corner frequency. In other words, at corner frequency there will be change in slope, right? So here this diagram has totally 3 corner frequencies, because the given diagram, that is the value of slope, changes at 3 different points. You see, initially it is -20, at this point it gets changed to 0, and again at this point it gets changed to -20, and again at this point the slope again changes to -40, right? Now we are going to write the transfer function. So just for our convenience, I had splitted this Bode plot into 4 different parts. Part 1, part 2, part 3 and part 4, right? So when you observe your part 1, what does it indicate? Can you remember how we draw Bode plot? So the initial slope is given by the individual s term present in the given transfer function, right? So here the value of this slope is -20. What does it mean? It means that there is an individual s which is present in the denominator. Why I am telling it as denominator? Because here I am having a minus sign, right? So initial slope always indicates the constant along with individual s term, right? We do not know the value of constant, so let it be k. And this -20 is contributed by s in the denominator. So for part 1, we are writing the transfer function as k by s, right? Hope you people understand this one, right? Then the next thing is, we are moving to the part 2. So in part 2, what happens? The -20 gets modified into 0 dB, right? So what does it means? That because when you look at our magnitude table, that is, we will be forming a table number 1, right, for finding the magnitude plot there. So just for example, I had taken this table, right? So the initial slope is given by constant with individual s term, right? We don't know the constant in our problem. Okay, this is just for example, I had taken this one. Then what happens? Then the value of slope is given by this change of slope value. Okay, here how it becomes -40? Here that is -20, and again a -20 is added to it, so that it becomes -40, right? Now when we look at our diagram, initially we are having -20, then it becomes 0. So what does it means? That there is an addition of +20 to this value, so that we are getting the answer as 0 dB, right? That is, here we are having -20, right? So -20, here the final answer is 0 here. So what should be added to this -20 to make it 0? We should add +20, so that the answer is 0, right? So what does this +20 indicates to us? That is an s term in the numerator part, right? Hope you are clear with this. So here for part 2, you see, I had written k by s as such, and here that is an addition of an s term in the numerator part, right? So here I had written the value as 1 plus s t1, right? Hope you people understand this one. Now we are moving to our part 3. So here What happened in our part 3? Again this 0 dB slope gets changed to minus 20. Right. So what does it indicate? Minus 20 indicates there is a term in the denominator, there is an S term in the denominator. Right. So because here we are having minus 20. So we have to include a new term in the denominator part. Right. So in part 3 you see you have to write all the terms in part 1. So k by s into 1 plus st1. So in part 3 we had find out there is another s term in the denominator. So here we are writing it as 1 plus s into t2. Right? Hope you people understand this one. Since we are having minus 20, I had included an s term in the denominator. Suppose if I have plus 20, then I have to include this s term in the numerator part, not in the denominator part. Right? So next we are moving to our part 4. So what happens in our part 4? You see that the previous slope is minus 20, but here I am having minus 40. What does it means that? So initially I am having minus 20. So what should be added to this minus 20 to get minus 40? I should add another minus 20 to get the value as minus 40. Right. So what does that minus 20 means? It means that again we are having an s term in the denominator. Right. So here in our part 4 you have to write all the terms which are present in our part 3. So along with this I have to include another s term in the denominator part. Right. So finally this is our transfer function. The value of k can be find out in a given problem. So this is just an introduction video. So I am stopping with this. Right. So when you look at this diagram carefully, you see how many corner frequencies you are having? You are having 3 corner frequencies. So what is meant by corner frequency? Whenever there is a change of slope occurs, we are naming that point as a corner frequency. Right. Now you see, since we are having 3 corner frequencies, in our transfer function, you see we are having 3 terms, that is 3 terms with s. Okay. So what is a corner frequency? Corner frequency is nothing but when you take reciprocal of the coefficient of s. So here omega c1 is nothing but what is the coefficient of s here? It is t1. So when you take reciprocal of 1 by t1, that will give you omega c1. Right. Again similarly when you take reciprocal of T2, it will give you omega C2. When you take reciprocal of T3, it will give you omega C3. That's it. Right. So you see we are having 3 corner frequencies. So we are having 3 elements, that is in this format, 1 plus some term with s. Right. Since the initial slope is minus 20, here I am having an s term in the denominator. There will be some constant. Okay, even the value of constant may be 1 also. We don't know. It depends upon the problem which is given to us. Right? Hope you people understand this concept very well, I believe. If you have any doubt, let me know in the comment section. Thank you.